balance board project. Would you like to show that to the whole class at the end of the review session? Sorry? Yeah? These guys did a really cool project, which I'll let them describe, but it used a lot of the knowledge from this course to achieve something cool. So I'd like the rest of you to see that, you know, this stuff is actually useful and can be put to use. So yeah, we're not just teaching nonsense in this class. So I guess we'll just give it another minute or so for the stragglers to show up. But, how is everybody?
Good. We're alive.
Good? Still alive? Good. It's good. I mean, being alive is really all you can ask for at the moment, you know?
Yep.
Yeah. Like, do I have enough food to eat? Yes? Okay. Things aren't as bad as they're going to get then. Yeah. I suppose I should be Mike, shouldn't I? Test. 1, 2, 3.
It's around 9.
Good. So the exam then. I should preface this by saying that I actually have written the exam. That is to say, the exam has been submitted to the examinations office. So it's now set in stone. There's nothing further I can do. It's out of my hands. So when I speak about the exam today, I will be speaking intelligently, knowing, in my brain at least, what's actually on it.
Can you do
So,
this practice problems?
sorry?
Can we do the exam things as practice problems?
No. But that's a good try. We can do some practice problems. They'll be related to the exam, but, you know, they won't be the exam, because that would be, you know, cheating, so, you know. So, the exam starts at 9 a.m. this Thursday. It's 2.5 hours long. I don't expect you should need all of that time, but it's there for you. Whether or not you take it, it's there for you. Permitted aids, you are permitted 1 double-sided crib sheet. That is to say, you are permitted 1 piece of paper, double-sided, standard 8.5 by 11 size, upon which you may inscribe any knowledge which you feel fit to bring into the examination. I have a couple of do's and don'ts of crib sheets, which I'd like to share with you now, because how many of you have written a paper exam so far? How many of you have not? How many of you have not written one with a crib sheet? Well, that would be a superset of those who have not written one in paper. So there are some important do's and don'ts related to crib sheets, right? Do not just fill the crib sheet up with the slides directly translated, all right, or directly copied. Don't just shrink all of the important slides down to minuscule size and just fill the paper with them. Bad strategy. I've seen it done, though, many, many times. I'll explain to you why it's a bad strategy. Number one, it becomes very, very difficult to find anything, right? It's not just having the information in front of you, it's also being able to sift through that information and find the particular thing pertaining to what the question is asking for, right? The longer it takes you to find something on your crib sheet, the longer the exam is going to take you, and you may just run out of time, right? So from that perspective, bad strategy. From another perspective, the act of transcribing everything you think is important onto your crib sheet is an excellent way to study just in and of itself. By writing the crib sheet out, you are studying for the exam. So you can kill two birds with one stone, right? With respect to the stuff to go on the crib sheet specifically, I highly recommend any equations that we had in the course so far. Those would be of particular use on a crib sheet, I would say. Aside from that, it's up to you what you want to include or not include on your crib sheet. You know, it's yours. Have fun with it. Don't use someone else's crib sheet. Not because it's academic dishonesty, but because, for the same reason that creating the crib sheet itself is, you know, in large part the act of studying. So if you use someone else's, you haven't studied, right? Like one of my favorite comics is this guy who's like this guy playing video games, and his roommate comes in and says, "Don't you have an exam on Tuesday?" And he's like, "Oh yeah, no, that's fine. I'll just borrow my brother's cloak of wisdom." So he gets to the exam, he puts on the cloak of wisdom, he gets plus 10 wisdom, and his eyes go wide and he says, "I should have studied." Right? So, study. Anyway, so in addition to the crib sheet, you're permitted the McMaster Standard Calculator. There's not going to be a huge amount of hand calculation needed, but, you know, there will be numbers on the exam, so be sure to bring your calculator. But yeah, I think that's everything I have to say with respect to the format of the writing itself, except you will have both a Scantron sheet and a test booklet included with your exam. So if they don't give you both of those, tell the invigilator I got shortchanged. You got to give me one or the other thing I'm missing. Question?
Can we get like an approximate percentage of like what's multiple choice, what's true, false, what's fill in the blank?
I don't. Only Siths deal in absolutes.
I see.
I will speak vaguely, but I will not give you like this many questions of this, that many questions of that. It's just not my style.
I see.
Yeah. Question?
Will you let us redo the midterm on Avenue as practice?
No. Sorry.
Oh, good.
You can redo the quizzes though, and the quiz material and the midterm material is like very similar. So, yeah. Any other questions? Okay. So, so having talked about format, let's talk about content. The exam is cumulative over all of the topics of this course. You can expect all topics to be represented. Of those, previously I was saying that the exam is likely to focus more on the second half of the course to the exclusion of the first. Having actually put the exam together at this point, I would say that it's certainly worth reviewing the first half of the course as well. It's going, again, I'm not going, speaking only in vague terms here, but you're definitely going to see some material on like GPIO and timers. You're going to see some on I2C communication. You're going to see some on the dreaded interrupts, although I tried not to kill you with those questions, because I know how that went. You're going to see some questions about the economics stuff. You're going to see some questions about operational amplifiers. You're going to see some questions about all of the topics that I'm forgetting about as well. Basically, I went through and I did a tally of how many questions were on each topic, and every topic has at least one question about it. So there you go. That being said, a large proportion of the test will be multiple choice. So one question, if that's a true or false question, isn't a lot, but at any rate, question.
Are we seeing any lab questions?
There are a couple of lab questions in there as well, yeah. Question.
Will we be expected to write code based on the lab?
No.
Okay.
No, you will not be expected to write code. Yes?
When you say only a large portion is multiple choice, are we expected to write out full solutions for some questions?
Yes. Yeah, there is not just, so the test, or the exam is not exclusively multiple choice. There are a couple of, basically it's broken into 3 parts. You've got the straight multiple choice, right? You've got some short answer questions, which are largely numerical questions, right? Not to give anything away, but, a lot of the economics questions were calculate this, Those went in a short answer type category rather than being a multiple choice question. Because I always find it stupid when it's calculate this formula, and then it's 4 possible numbers. It's a personal pet peeve of mine. And then there is a section for long answer questions. Let's just say that one of the examples which I hinted that we'd be talking about today is probably going to be quite relevant to the long answers portion of the exam. Any other questions? Yes?
Am I allowed to ask if we have to worry about Thevenin analysis?
You can ask, but I don't necessarily have to answer. So Thevenin analysis and analog to digital conversion are they are certainly topics we covered, but I will neither confirm nor deny whether or not Thevenin analysis appears on the exam. Okay? Any other questions? Yes?
On a side note, can you give us the answers for quiz 5?
Yeah, we can shoot me an email about that. I'll get that out sometime tonight or tomorrow morning. Okay? Yeah. Any other questions? Okay. Well, in that case, I'd like to commence the proceedings by doing a great big long example on the board. So hopefully everybody's paying attention. So although it was something that we covered relatively late in the course, single-purpose processors are a very important thing, for your general engineering knowledge. So I thought that we might go through the Collatz algorithm. How many people prepared this over the weekend? One guy, okay. Yeah, okay. So, all right, that's fine. The Collatz algorithm, right? Anybody remember that from an exam that they might have written, last semester?
Yeah.
Anybody want to give me the Collatz algorithm? Yes.
So if it's odd, it's 3x plus 1, and if it's even, it's divided by 2.
Right. So the Collatz algorithm is a sequence of numbers. So for any, let's say Collatz at n plus 1 is equal to 3 times Collatz at n plus 1 if colats at n is odd, and colats at n divided by 2, I'm just going to put braces around that so it doesn't look like it's n plus 1 because that's confusing. Oh man. Okay. We'll do this right. We'll make it so that it looks pretty. I'll try anyway. So 1 plus 3 times c at n. No ambiguity. And then so it's that divided by 2 if c at n, cn is even. The Collat's conjecture is a mathematical property that given any starting integer given any starting integer greater than 0, the Collat's, if you follow this algorithm long enough, it will eventually arrive at 1. This is the Collat's conjecture. This has never been proven to be the case, but has been the case for numbers as large as we've been able to look. So it's, it's like one of these mathematical results which is presumed true, although there's no proof of it specifically. Unless somebody has proved it in the last 2 years or something. Because they had nothing to do during COVID, so they proved the Collat's conjecture. But anyway, so it's relatively easy to write a C algorithm for this guy, right? Well, we'll write it in pseudocode. But before we do, our object is to define a hardware module which calculates a Collat's chain, right? So let's do the bug view, right? Let's design an IC. We'll have a go signal, right? We'll have an in, right? We will have an out. We will have a count out, and we will have done out. And I'll just do underscore in here for the sake of consistency. So, yes.
So is that something you would give to us on the test?
Yes. Yeah. There is going to be a point in this derivation where I will give it to you up to some point on the exam. At a certain point, I'm going to stop answering the question, will you give us this far? This, I would not expect you to derive this because I put this in the category of a specification, right? Yeah, like, how would you know that I expected you to not only tell me what the current Collat's number is, but also how many Collat's iterations we've done? How would you know that, right? So, this is what our IC is going to look like. So let's do the algorithm, right? So, starting off, we'll have some internal register n, which we will assign n in to at the beginning of this, right? We'll have a loop while not go, go in, right? And all of this will be inside an infinite loop, and yeah, okay. I know what I did. Sorry. So, infinite loop. This guy is our waiting for the entrance condition, right? Questions?
Sorry, do you mind just moving it to this middle board here? It's kind of hard to see from the side.
Yeah. Oh yeah, I could turn on more lights too, yeah. Yeah, okay, I'll do it on the middle board. Jeez. Fine. I'm gonna have to rewrite the whole thing though, you know? Jeez. There we go. And there was light. Alright, so. Big ol' infinite loop. While 1. We wait for the go signal, right? While not go, do nothing, right? N is equal to n underscore in, which is our input signal, right? Now, we enter into the collapse loop. But first we initialize C to 0. While n is greater than 1, if n mod 2 is equal to 0, we do one thing, else we do another thing. The thing we do, if it's even, n is equal to n divided by 2. The thing we do if not, n is equal to 3 times n, I suppose it's asterisk plus 1. With me so far? Good. When that loop has finished, we set done equal to 1. Now there are a couple of things that are implicit in this. Done is reset when the loop resets and stuff like that. So we'll just, it's done underscore out, isn't it? So that's why this is like pseudocode, because there's a certain amount of this which is like implicit in the semantic, which you wouldn't necessarily know, right? Questions? Question?
Does the implicitness also count for setting count, as well as the fact that num n would be more than just a 0 or 1?
Oh, no, I just forgot count. I'm just gonna, okay. Let me squeeze them in. Count is plus equals 1. There. Okay. Actually, I added count since I did my little example in my book. So if I forget anything related to count, it's because I'm adding him on the fly because I think he's interesting and an interesting example. So thus far, so good. So far, so good. Any questions? You're right at the back, sir.
What about n out?
And out. Oh. That will become clear as time progresses. Our next step is to design what? Anybody?
Finite state machine.
Finite state machine, or because there's two things we need, right? We need the finite state machine, which describes the controller, and starts with a D.
Diagram.
Diagram is not specific enough. What kind of diagram is it? All right, it's charades. All right. One word. I'm not supposed to speak on it. One.
Three syllables.
The jump.
Year?
No, sounds like.
Oh.
Kiss.
Breathe?
It's data path. The thing you're missing is the data path diagram, which is like half of the design of the controller. Come on, Steve. Did you say data path?
Data path, you just ignore me.
Oh, well, you didn't say it loud enough. You should have shouted at me.
Yeah.
All right.
Wait, but what's
Yeah.
what
All
was
right.
this supposed to be?
That's. I was going for like sounds like say, day, that was the first syllable, right? Yeah. All right, I will not teach the class anymore using Victorian parlor games. Praise be to God. So, data path. All right, how do you design a data path? What's the first thing you identify from this? Variables, yes. They are the sequential data elements. So, we have a register for n, and we have a register for c. Jeez. So, what operations do we need? Addition with what? All right, so, all right, no, you go through them in sequence, all right? This is an operation. We need a greater than one module. We need,
Modulus 2.
well, you could, no, for the division, yeah, you can use right shift for it, but let's just keep it out of bitwise and not keep it confusing, or keeping less confusing. Let's not make it as confusing. That's what I'm trying to say. So we need a mod 2. We need comparison. Remember the comparison block from earlier? We need a constant 1. That'll be fed into the comparison. N mod 2 will also be fed into comparison. Comparison has 3 leads, right? You guys remember this from the slides? You've got greater than, less than, and equals. So this is the equals signal off of comparison, right? We need division. Divide by 2. I'm going to move this guy over here because this is a squishier diagram that way, right? Divide by 2. We need times 3 and plus 1. So we need times 3 and we need plus 1. Some of these should have constants coming off of them like this, like I did with the comparison, but I've just built them right in here because it saves a lot of space. All right? Makes the diagram less complicated. But in this case, since I wanted to illustrate that this was the actual comparison block, you know, it is what it is. So, we've got this, we've got that, we've got this, we've got that, we've got that. We just need this one, and there you go. So we need a plus 1 module here. Now we just have to hook them up, right? So this is the data path. Any signals traveling this way will be headed to the controller, right? So we need to know if n is greater than 1. We'll call this signal NGT1, right? N is greater than 1. Yes, question?
Why can't you use the previous plus 1 that's already there?
I don't want to add a multiplexer.
Okay.
Yeah, I mean, you can, but like, I don't want an optimized solution, I just want a solution at this point.
Yeah.
But yeah, you're totally right, you could add a multiplexer and use this one twice and that would make it more efficient.
Okay.
Yeah. Any other questions at the moment? Yes?
Well, to follow up with that, will we need to make an optimized version, like for exam?
You should be aware of the types of optimizations which can occur. So we need that. We need the equality signal coming off of the comparison. So we can call that n is even. Right? Or I suppose this way it's odd, isn't it? We want to put a 0 here to see if it's even. Yeah, that makes sense. Okay, cool. We need n to feed into division by 2 and to feed into times 3 and then subsequently into plus 1. You guys following this, right?
Yeah.
All we're doing, n is the value that's currently held for the variable n. In order for these operations to be populated with the value of n, you have to make a wire that goes into them from the register n. Right? These are not controlled in the same way that loading registers is controlled. Right? If you have a register, you can read the value from that register freely. Question?
All the operations there, just like you did for the comparison between we need to feed in a constant, to like to do modules, do we need to feed in like 2 and then to the modules?
I would be fine with it if you did it this way on the exam, because like, in a sense, it's just busy work, you know? But I just, for this one's a little bit different. Like, in theory, I could have done like equal 0, and that would, you know, on an exam, that would get you the same amount of marks, you know? I'm being slightly pedantic there, all right? It's not necessary for you to exhibit that level of pedantry, all right? All right, any other questions? We're way at the back, sir.
How do we know which variables go to the controller side?
So, that's a good question. So, let's identify, based on this pin diagram, what is data path, what is controller, right? Let's consider go_in, right? Is this something you would feed into the controller or the data path? What? To the controller, because the controller is the thing that makes it go. So it receives the input go signal. Is n in data or a control signal?
Data.
It's data, so it gets attached to the data side. N out and C out, are those data or control signals? Those are data, right? Not least of all because they're derived from a data signal, an input data signal, right? Done out, is that control or data?
Control.
It's a control signal. This is a reasonable heuristic, but it's not absolutely the case. Whichever of these are Boolean signals will typically be control signals, and whichever of these are integers or floats or fixed point arithmetic will typically be data inputs and data outputs. Make sense? Good, that's a good heuristic. So, we can continue hooking things up. C must yield into the +1 module. So, now let's address ourselves to these guys. The input into the register will be multiplexed, right? How many different ways can we assign to n in this program? Yes? All right. 3, yeah. We do it here, here, and here. We have 3 different ways of writing to n. Multiplexers only work on, base 2 basis. So you can have 2 input multiplexers, 4 input multiplexers, 8 input multiplexers, etc. In this case, we'll need 4 because 3 is greater than 2. So we've got 4 input leads here, corresponding to values as such. Right? From that multiplexer, we will have 2 selector signals. We'll call them n select 0, n select 1, I will probably group them together and refer to them collectively at some point once we start doing the state table. Make sense? How many possible ways can we write to C?
1.
Are you sure?
Oh, sorry, 2.
Yeah,
Two.
we've got it here,
Yeah.
and we've got it there. Good. So, zero and 1, and I'm just gonna do that because I don't want to pull it all the way around. And that'll be C select. Right? So, now we have to decide how the results of these 3 guys get filled into up here. And so, what's the in the program, what's the first thing that we write to n?
N equals N in.
N in, right. So if we have an incoming signal n in, let's feed that right into the 0, 0 input of the multiplexer. Right? Making sense so far? Next one, n divide by 2. So we take this, feed it in, then we take this guy, feed that in, and then we can leave this one disconnected. Right? The intersections are, places where the lines intersect are indicated by the little knobs. Right? Any questions? Yes?
Is that arbitrary or like those specific things are
It's a design decision. So yeah, arbitrary.
And what, sorry, what's the line again, like the furthest, most furthest?
This guy?
Yeah.
Oh, that's just like the border of the data path unit. Anything coming in the top here, that'll be exterior to the processor. Anything traveling this way will be communication to or from the controller.
So this is all data.
This is all data path, yeah.
This is going to
This is coming, yeah, actually I should reverse these arrows because they are coming from the controller, not going to it. So yeah, there we go. There. Make sense? Question?
Are the numbers and multiplexer arbitrary?
Well, it's binary counting, but yeah, yes, they're arbitrary. It's, you know, this one will be selected when both these are 0. You know, when it's 0, 1, it'll select that one. But which of these get connected to which of those, that's just an arbitrary design decision. You have to choose something, so you just choose something.
So all it serves to do is just choose which input's going to be taken this time.
Yeah.
Okay.
Yeah. Question?
Your camera's out of charge.
You're kidding.
Yes. No,
Oh.
it's out of charge.
Well, I guess this is the subscribers only portion, so great. Sorry about that, folks. I charged it last night.
I'll keep recording until it dies.
Yeah, okay. All right, well, at any rate, so that's the N-related side of things. This one's easy, right? We either write 0, the constant 0 in here, or the results of +1, right? So here's another arbitrary design decision for you, which has to relate to how N out and C out are determined. I am just going to arbitrarily decide right now that N out is whatever the current value of N is, and C out will be just whatever the current value of C is. Right? Does that make sense? I had some questions over here. Did you guys, question?
Yeah,